Hi everyone, welcome to part 1 of 2 of evaluating trig functions using the unit circle. In this video, everything we're going to do is going to be a degree or a radian on the unit circle. I'm going to do a second video that covers things that are like coterminal with things on the unit circle and what you're going to do when you have to like rationalize denominators and stuff. But this video is just going to be the basic find the sine, cosine, tangent, cotangent of the numbers you see right here with the pi's or the things with the degree symbols. So to start off, I like talking a bit about why all of the stuff I'm about to say is true. If you don't care about why all the stuff I'm about to say is true, then you can just go ahead and write in your notes right now that cosine is the x value and sine is the y value. And that would be it for your notes. If I say what is the cosine of 5 pi over 6, then cosine is the x value. So the x value at 5 pi over 6 is negative root 3 over 2, and that would just be your answer. Feel free to fast forward. Otherwise, hey, let's talk about why all this crap is true and why it's awesome and stuff. Why the heck is cosine equal to the x value on the unit circle? And it has to deal with triangles. I'll go back to here. Let's pretend for a second that I was to draw a little line right here and to make this an actual triangle. That is a right angle. As it implies, this is 30 degrees right here, right? If we're going to right there at 30 degrees. What happens is the unit circle, if you've forgotten, is defined by one thing. And that is that its radius is 1. So the radius here is definitely 100% 1. Back in the day, you might have talked about the special 30, 60, 90 triangle. 30, then 60, 90 triangle. In which case you had, well, if this side is 1, then this side is 2, and then this side's the square root of 3, and those are just the special ratios. Maybe you remember that, maybe you don't, doesn't really matter. It's just true. This is a triangle, 30, 60, 90. If this side is root 3 and that side's 1, the other one's 2, you could always use Pythagorean theorem. This squared is 3, 3 plus 1 is 4, and the square root of 4 is 2, but whatever. The whole point about this is that if you divide both sides by 2, you would get a triangle that says exactly this. 2 divided by 2 is 1. Square root of 3 over 2 is this distance right here. This distance right here. And 1/2 is that distance right here, or that distance right there. And in any ordered pairs, you know it goes x, y. So it goes over square root of 3 over 2, up 1/2. So over square root of 3 over 2, up 1/2. That's where that comes from, and then everything else comes from the exact same thing, except here everything is positive, and there it's negative, positive, etc. Why am I saying all this? Because SOHCAHTOA. Don't you know? Maybe not. Because otherwise you wouldn't be watching this. SOHCAHTOA says that sine is the opposite over hypotenuse. And if we were to look at this triangle right here, this is the adjacent, this is the opposite, and this is the hypotenuse. So if you were to look at the opposite over hypotenuse, the opposite is this, which we said was 1/2, over the hypotenuse of 1. So sine is 1/2 over 1, or just 1/2. Whereas the cosine would be root 3 over 2. Maybe I'll just write them here so it's easier to see. So root 3 over 2 divided by 1 is just root 3 over 2. And it just keeps going like that. Since the hypotenuse is just equal to 1, sine just becomes the opposite over 1, or just the opposite side. Cosine is adjacent over hypotenuse, but hypotenuse is also just 1, so cosine is equal to the adjacent. but the adjacent sine is equal to the x value. So cosine equals x, and then sine equals y. There you go. So that's why everything turns out the way it does. Tangent, opposite over adjacent, that's the same thing as y over x. So tangent turns out to be y over x. So you have to do division there, whereas the other ones are just copy-paste kind of what's the y value or x value. So that's all the reasoning stuff. If you care about the reasoning, hopefully that makes sense. If not, you can rewind it and watch it again. And if you don't care about y, then today's your lucky day. Woo! Let's get rid of this thing and go on to do a question. So here we go. Let's just start easy peasy. Find the sine of 330 degrees. What you do is you get back to that piece of paper that I threw over there and landed on the floor. And you go to 330 degrees. So over here at 330 degrees, I have this ordered pair right there. So I'm going to go ahead and write that ordered pair down. Root 3 over 2, comma, negative 1/2. Sine. Sine is supposed to be the y value. So I'm going to go over here, and which one is the y value? This one, because any ordered pair is an x and a y. So the answer is negative 1/2. The sine of 330 degrees is negative 1/2. 2. Let's say I wanted to do the cosine of 5 pi over 4. Maybe this time I'll say, oh yeah, cosine is the x value, so I'll write myself that little note first. I'll go to 5 pi over 4, and I'll see what the x value is. So search, 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 search. 5 pi over 4 is this one right here. So the negative root 2 over 2 over this thing. Okay. And I want the x value. So for cosine, the x value is this thing. So the answer is negative root 2 over 2. That is the cosine of 5 pi over 4. Like I said, this video is simply showing you that. If the radian is on here, you go to that ordered pair and you write it down. And then cosine is the first number, sine is the second number. Some people like writing that down, but cosine is the first number and sine is the second number. And you just copy down whatever number is there once it gives you the angle. Okay. Tangent. Let's go tangent of, let's say, pi over 3. At pi over 3, right there, it's this ordered pair right there. So 1/2, comma, square root of 3 over 2. Now, tangent is supposed to be y over x. Y over x. So, if this is x and this is y, you want this divided by that. The square root of 3 over 2 over 1/2. And then you would simplify this to get your answer. Now, as I said, I'm doing that in a separate video. This is not the actual full life answer. The actual answer is going to be just the square root of 3. Simplifying to there is my other video, which is why I suggest you watching it. If you can figure out this to that, then good for you. But you would have to simplify it, but I'm going to show that in a separate video because I don't want this to be too long. Okay, next up, let's try something with secant. I forgot what number we're on. Doesn't even matter, but it matters in my mind. Let's go with secant of 0. Aha! This time, you first have to remember what the heck secant is. It is a reciprocal. It is either reciprocal of sine, cosine, or tangent. Which one? Cosine. It is the reciprocal of cosine, which means you are once again going to be looking at the x value, but you are going to be flipping it upside down kind of dealio again. So you're going to look for the x value at 0, and we're going to flip it over. So we're going to go to 0. We're going to look at the x value, which is 1. Right? So this is the x value, but then you have to do its reciprocal. Now, in this one, 1's reciprocal, 1 is technically 1 over 1. And then if you flip it upside down, it just gets to be 1 over 1 again. So this one, not anything really exciting happens. But you do have to know that you take it and you flip it upside down. Such as cosecant of, let's go, 4 pi over 3. In this one, cosecant is the reciprocal of sine, which is my y value. So I'll remember it's my y value. I'll go to 4 pi over 3, boop, right there. 1/2 root 3 over 2, both negative. Sine is the y value. So I'll go over here, this is the y value. But, once again, it's cosecant. Cosecant's the reciprocal. So you have to take this and flip it upside down. So instead of negative root 3 over 2, it's going to be negative 2 over root 3. Like that. Which is not simplified. You'll simplify it in your answer, which I'm showing you in the next video. But that is what you do. You flip it upside down. If I had asked for the secant of 4 pi over 3, then it just would have been the x value. It's the same thing, it's just this time it's the x value. So you would take negative 1/2 and you'd flippy-floppy it upside down to get negative 2 over 1, which is just negative 2. So that has to happen. Okay, I'm going to call it there on this video. The next one I'm going to go over simplifying tangent, cotangent, secant, cosecant, as well as when you have to do coterminal angles in order to find something on here. Have a good one. See you soon.